What's going on, guys? Let's do this problem right here. Let's see how we can calculate the volume of the region bounded by y is equal to x square and x is equal to y square, and it's rotating around x-axis. So let's see how we can find this. So first of all, we have to draw the graph. Okay, so if we draw y is equal to x square graph, we know that it's parabola opening up. So we are going to have a graph like this, right? So we are going to have a graph like this, and x is equal to y square. That's going to be parabola opening, right? Because if you notice, like for y is equal to x square, this y values must be positive, right? So x is going toward positive y-axis, and x is equal to y square, it's going toward positive x-axis. That's the difference. So here this is going to be opening in the right side. So let's draw like this. So this is going to be the graph. The region we are interested in is this region, the region between those, right? This is the volume of the region we are trying to find. So let's see how we can find it. So first of all, we have to know the volume equation. Volume equation when we have two curves bounded together, that is v is equal to phi integral r out minus r in square, r out square minus r in square, r in square. Here this is rotating around x-axis, so this would be dx, right? So this is AB, and r out is basically when, for example, if you draw a line like this, so wherever the line touches last, that's going to be the outer radius, and wherever the line touches inside, first, that's going to be the inner radius. So this is r out. So let's write in a different color. Okay, this is r out and this is r in, right? So what is going to be the r out? R out is basically the function of the graph. For example, this is the top graph is x is equal to y square, right? We know the equation of this graph is y is equal to x square. But if you look at this one, that's in the bottom one. That's going to be the inner radius. So this is y is equal to x square. And the top one is x is equal to y square. So that's going to be the outer radius. So here we are going to write outer radius minus inner radius. But if you look at the outer radius, that's in terms of y. We have to write in terms of x. So let's rewrite this one. So if you equate y, that's going to be equal to, if you square root both sides, that's going to give you y value. So here we are going to get y is equal to root x. So that's going to be the outer radius. So let's plug these values in this equation and find the answer, right? So here if we plug this one, we are going to have, and before we do that, we have to find the limits of integration, and we know this is starting from 0. So that's clear. To find the other limit, b part, we have to know this location right here. To find this one, what we can do is we can take these two equations and equate both of them. That's going to give us the common junctions, right? So that's going to be the limits of integrations. So let's go ahead and equate those. So first we have y is equal to root x, and the other one is y is equal to x square. If we equate both of them, x square root x is equal to x square, and let's bring them together to one side. So here we are going to have root x minus x square is equal to 0, and if I square this one, square both of them, that will make it this one simpler. This is going to be x minus x power 4 is equal to 0. Now I can take x common, so this is going to be x times x minus, 1 minus, so x times 1 minus x cubed is equal to 0, right? So from this one we know that x is equal to 0. We found out one already, but we have to know this function right here. So from this one, the other one that is saying negative x cube is equal to minus 1, therefore x cube is equal to 1, therefore x is equal to 1. So we know that this is going to be 1. right? So this one is 1, this is 0. So the limits of integration is going to be 0 to 1. So here we are going to have 0 to 1, and outer radius is going to be the top function of the top graph, that is y square is equal to x. We want the y in terms of x, so y is equal to root x. So we are going to have root x square minus inside function, inside a graph function, that is y is equal to x square. So we just have to write x square right here, and this is square dx. Let's do the simplification. If we simplify, this is going to be integral 0 to 1. If we square root of x, that's going to be just x. And if we square x square, that's going to be x power 4 dx. Now we can integrate this one. If we integrate this one, that's going to be 5 x square divided by 2 minus x power 5 divided by 5, going from 0 to 1. If we plug 1 for this one, this is going to be 5 times 1 square divided by 2 minus 1 power 5 divided by 5, minus, if you plug 0 for these values, it's going to be 0, because x, if x is 0, everything is 0. And other one is so same thing. So we can just put 0 right here. And this is going to be 5 times 1 over 2 minus 1 over 5. If we take 10 common denominator, so if we take 10 common denominator, this is going to be 5 minus 2, and that's going to be equal to 3 5 over 10, and that's going to be the volume of this shaded region. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.